Today's assignment is a review for our Chapter 4 test, which we'll have tomorrow. As you go through these problems, I'm going to just go through and go through each problem. So after you have a chance to look at it, you'll want to pause the video, try the problem, restart the video, and watch its solution. So I'll give you a second to look at the problem and pause it before I start my solutions. And I'm just going to go through all the problems of our review like such. Okay. So if you had a chance to look at the first two problems, pause the video, and then go ahead and do it, and I'll give you a solution. Okay. For our solution to these, we're trying to find out how many people there would be in one day. Unit rate means one. Likewise, for the second problem, how much money it would be for one ticket. Okay, so unit rate, first of all, the key is making sure you understand that that means how much for one. In the first problem, if we took 405 and divided by 15, because one number over another number means to divide, we find out that it's 27 people in one day. And labels are important for that. If we just said 27 over 1 or just 27, we would have no idea what you meant. But 27 people in one day has some meaning for it. Second problem, again, we take the numerator, which is $84.78, and divide it by our denominator, which is 4. We find out that it's $21 and give them 0.195, which would round up to 0.20, because again, money should always go out two decimal places. So there you go. So that's what a unit rate is. After we looked at doing unit rate, we then wanted to look at how to use unit rate within a problem. So we have one rate for Bob's. We have a different rate at Stan's. We want to find the unit rate for each so that we can compare. So we'll do Bob's first. 25 divided by 7 means that he does about 3.57 gears in 1 minute. Again, it's just finding the unit rate for that, just like we did above. At Stan's, we have 37 divided by 9.4 minutes. We find out that he does about 3.93 gears per minute. Once we've got that, then it's much easier to answer the question which place works at a faster pace or makes more. And Stan's makes more because they have faster rate. Okay. Good. Second type of problem we're going to look at is, first of all, taking a look at just solving a proportion. So if you have a chance to stop the video, solve these proportions. Alright, as we look at solving a proportion, we look at cross multiplying and dividing. You multiply the two you can and divide by the other. So 15 times 32, and then divide that by the 25. Tells us that it's about, K would be 19.2. In our second problem, again, we look at doing our cross multiplying and then dividing. So 120 times 10 divided by 21 gets about P equals 571.4. Good. Once we looked at how to solve a proportion, then we looked at how to use a proportion. Now, alright, hopefully you've had a chance to solve this. If not, stop the video so you can. Solving a portion is just very simple. Now we just have to set it up first. So we start with what we know about Mary. We know that she can swim 7 laps in 24 minutes. We set that equal to what we're trying to find out about her. We're trying to find out how long or how many minutes it would take her to swim 50 laps. And the key there is to make sure that our label on the top is the same on both sides. The label on the bottom is the same on both sides. That will ensure that you have your proportions set up correctly. Now we just like the problems above, we cross multiply and divide. And you find out it takes about 171.4 minutes. Okay. Our next set of problems, we're looking at two figures that are similar. Figure A is similar to figure B. So using that knowledge, we want to see if we can find out how long side K is. So see if you can set up this problem and solve it. Again, you're looking for two pairs that correspond where you know them both. All right, let's see if we can set this up. So if I look at this little slanted side, can't use those, so I don't have them both. Let's look at the little flatter side. I know that's 10, and that matches up with, oh, I don't have those both. So I'm looking for a pair that where I know them both. So if you take a look, this 21 is the top above that angle part. That matches up with this part above that angle part. So I'm going to write that down. 21 inches corresponds with 35 inches. Okay. The next thing I'm going to do is say, okay, I'm looking for this side K, and it's the shorter side of the two, I guess, sides. Here's the shorter side of my two sides. So K matches up with 24. Key is which one's going to go where. Am I going to write K over 24 or 24 over K? The easiest way to do this is I like to always put my smaller figure on the top and my larger on the bottom. And that's how I had it in the first one. So since the 24 comes from the smaller, it goes on the top. I'm looking for how long that side K would be. And again, once it's set up, we simply cross multiply and divide. And this turns out to be exactly 40 inches. Again, a majority of this test can be set up with cross multiplying and dividing out of proportions. Classic height, we won't go through this problem, but remember, we're always going to try to find the height of something with relationship to its shadow, and the height of something smaller with relationship to its shadow. So if we look at this, we got our flagpole with a shadow of 12 feet. We have the person's height, which we know at 5.8 feet, and his shadow at 2.3 feet. And now if you kind of look, we've got these similar triangles like we just looked at. So if we look for parts that match up, well, the bottom parts are the shadows. 2.3 from the man matches up with 12 feet. And again, I like to use the smaller one on top. So now the man's height of 5.8 feet has to match up with the height of the pole. Once it's set up, we can just do our cross multiplying and dividing again. Find out that the height of the pole is about 30.3 feet. Again, if you set up the person's height with his shadow and the object's height with its shadow, it's just using similar figures. Right. Scale factor. We have our original point of K, and we're trying to find out where the new K or K prime would be if we use the scale factor of 2, and where M prime would be if we use the scale factor of 2/3. So see if you can do those and find the new primes for those two numbers. When they gave you a scale factor, it simply means you multiply by those numbers. I'll multiply by 2. Here I'm going to multiply by 2/3. We'll talk about that in a second. The multiplying by 2 should be fairly simple. 5 times 2, 6 times 2. The first one was negative, so K prime is negative 10, 12. Now, the one thing about multiplying by a fraction is when you multiply by the fraction, we actually multiply by the numerator, but then since it's over, we divide by the new denominator. So I could take 12 times 2 and then divide it by 3, or I could do that the other way around, which I think is a lot easier, taking that 12 divided by 3 first and then times the 2. So 12 divided by 3 is 4, and 4 times 2 is 8. 6 divided by 3 is 2, and then 2 times 2 is 4. Much easier to do it in that manner there. Okay, we have some trigonometry problems. Okay. So if you can pause your video, try these. Okay. Our first problem here, since I'm looking for the angle, I have the side right next to it and the hypotenuse. That's an example of cosine. So the cosine of the angle, so I'm plugging this in to where my angle symbol is equal to the side adjacent, which is 23 over hypotenuse. Good. Now we're going to simplify. Well, I can't simplify anything on the left, so I just leave it, the cosine of the angle, but I can take 23 and divide it by 46. And since it's half, I know it's going to be 0.5000. And then this is where I use my book or my calculator to find out what the angle is. And since if I'm using my calculator, I'm looking for the angle, I need to use my inverse button. I find out that the angle equals a 60-degree angle. And again, important that you put the symbols on there. Okay. On the problem on the right, now I have this angle. I have the side adjacent and opposite. So that means I'm using the tangent and I have the angle, so I put it in there. Side adjacent is 9. Sorry, side opposite is K. Side adjacent is 9. Now I simplify, and I can't simplify anything on the right, so I leave it. I can find the tangent of a 74-degree angle, and that equals 3.4874. Now my goal is to get K by itself here, so I have to multiply by 9, multiply by 9. And if I do that, I find out that this side is 31.4, and again, you want to use the correct measure. K ended up being 31.4 kilometers. Okay. Then the last two problems are see if you can find the slope of those lines, the blue and the red. Remember, we're looking for slope, we're looking for the run with the rise over the run, which I like to think of as just how counting up and counting over. If you can count up and over, pretty simple. So in the first problem, I'm going to use these 2 points right here and here. I'm going to count up from here. 1, 2, 3, 4, 5, 6 over 1, 2 over 2. So my up was 6, my over was 2. If I reduce that, I just get 3, and it's in a negative direction, so it should be a slope of -3. Okay, we'll count our red one now, and I'll use these 2 points here. So I'm going to count up 1, only 1, over 1, 2, 3, over 3. So my rise is 1, my run was 3. Can't be reduced, it's in a positive slope, so that slope is 1/3. Okay. Homework for tonight is a worksheet. There is a copy of the worksheet attached to my webpage. Again, reminder, we will have a test tomorrow on Chapter 4.